we are going to do one more example with solving an equation by the completing the square process. So number 2, suppose we have negative 3x squared minus 9x minus 5 equals 0. All right, step 1, we want to get the constant term on the other side. So we are going to add 5 to both sides. So now we're going to have our negative 3x squared minus 9x equals 5. So remember, your steps are all back here on the last page. So constant on the right-hand side. Step 2, we have to get rid of any coefficient of the x squared term that is anything other than a 1. And we have that here. We have a situation with a negative 3x squared. So we are going to need to divide both sides by that negative 3. Now, on the left-hand side, no matter what, you have to divide each term in the numerator by that negative 3, even if it creates an ugly fraction in that second term. Now here it doesn't. Pretty nice on the left-hand side. We get our x squared and a plus 3x, leave a little room, and on the right-hand side, we have negative 5/3. Okay, now the completing the square step. So remember, we are adding something. It's always adding something, of course, to both sides. And it is the coefficient in front of the x term. It's absolute value, so I like to say just look at the number part. And so that's what we're going to take here. So we're taking this 3. So that, well, I shouldn't use the same color. That's hard to see. So we're taking that 3 right here, and that then is always what goes in this numerator. And then the rest of it is always the same. It is divided by 2, quantity squared. Okay, so whatever you do to one side, you have to do in balance to the other side. So you have to add in this 3/2 squared to the right-hand side as well. All right, now this is where I said, yes, it's a factoring step, but we really don't want to have to do the factoring every time because we never really did much, factoring with fractions. So we just want to kind of use the pattern that we saw last time, because essentially what we've created is a perfect square trinomial that every single time is going to factor into a perfect square, the same binomial times itself. Of course, your variable here is your x. Now, your sign in front of the x term is going to be the sign of your binomial. So this plus right here, that is the sign of your binomial. So that's the sign of the binomial. And then the number inside the binomial is going to be that b/2 number. So it is that number prior to the squaring. So it's this number right here. That's why I said if you can reduce it, definitely reduce it. If it divides evenly, great. But leave it as the quantity squared because that's the number we want in that binomial. Now on the right-hand side, we have to just do some arithmetic here. The 3/2 squared, squaring the numerator and squaring the denominator, I get 9/4. I do need to get a common denominator here because I need to simplify this right-hand side. So I'm going to go ahead and multiply the first fraction by 4/4, my second fraction by the 3/3. And so this is going to become negative 20/12. And then plus 27/12. And then now that I have my common denominator, 27 minus 20 is just going to be 7/12. So I have my x plus 3/2 quantity squared equals 7/12. So we go through all that work because now we have the x in just one location and we can apply the square root principle. So I'm taking the square root to get rid of the square. That means I have to introduce the plus or minus square root on the other side. So this one will be a real solution because it's not a square root of a negative, but it is kind of an unpleasant little radical to work with there. First thing, I'm just gonna, in this step, I'm gonna rewrite it as square root of 7 divided by square root of 12. And we're gonna need to, remember, like once you learn to do reduced fractions, you always have to reduce them. Once we've learned to simplify radicals, we always have to simplify them. Now we have a couple of choices here. That root 12, we're gonna need to do two things. We're gonna need to simplify the root 12 because there is a perfect square factor in there. We're also gonna have to rationalize the denominator. So just for right now, before we go on to the next step, let's just observe, it'll just give us slightly smaller numbers to work with, that this root 12 is root 4 times root 3, and that is going to be equivalent to 2 root 3. Okay, now the other thing we're going to have to do, so let's maybe at this point say, well, I'm also going to need to subtract my 3/2 here over to the right-hand side. So my solution is going to be x equals, and I have this negative 3/2, and then I'm going to have this plus and minus, and at this point I have it as the square root of 7 over 2 square root of 3. But I am going to want to rationalize the denominator for the final form of my answer. So just on this second term, I'm going to need to multiply by square root of 3 over itself. And now that would give me, in that numerator, square root of 7 times 3 is 21, divided by square root of 3 times square root of 3 is 3, and 2 times 3 would be 6. So my final answer here would be negative 3/2 plus and minus the square root of 21 over 6. Or again, writing those out separately, you could say negative 3/2 minus square root of 21 over 6 and negative 3/2 plus the square root of 21 over 6. So this is completing the square. You definitely need to know it. Even after we go on to something that you may or may not have ever seen before, quadratic formula, in the next section, students tend to like that better. There still will be times in other contexts where we have to kind of know about this completing the square idea. So you do need to know this technique. But as I said, when we come back in 11.2, we're going to learn another method to solve quadratic equations, which is a quadratic formula. Essentially, it's like completing the square done in advance for you and put into a nice little package. So we'll come back to 11.2 in the next video.